Hello students, welcome to Umadevi Children Academy. Student, today we are going to discuss the topic is covalent character of ionic bond and ionic character of covalent bond. We will discuss here, that is the Fezan's rule. So let's start. So when we compare the dipole moment of NH3 and NF3, both are pyramidal shape. Both have a lone pair of electrons on the nitrogen atoms, like this. Nitrogen atom react with the hydrogen with pair of electrons. Nitrogen atom react with the fluorine pair of electrons. Alright students. So here the electronegativity, the fluorine have a higher electronegativity than the nitrogen. So resultant dipole, the resultant dipole here the fluorine is greater electronegative than the hydrogen, so this pair of electrons are completely shifted on the fluorine atom. But here in case of nitrogen hydrogen bond, the hydrogen is less electronegative than the nitrogen, so pair of electrons are shifted this reason. So NH3 dipole moment is 4.9 10 to the power of minus centimeter cube is greater than the NF3 0.8 10 to the power of minus 30 centimeter cube. Okay, when we compare the nitrogen and here pair of electrons, so now hydrogen is the less electronegative than the nitrogen, so hydrogen positive, nitrogen negative. Again this one also hydrogen positive, nitrogen negative. Hydrogen positive, nitrogen negative. Right students? So then electronegativity towards hydrogen atom, so that's why its have a dipole moment is the 4.9, because all the orbital dipole, the lone pair of electrons in the same directions. Lone pair of electrons also showing the dipole moment this side, and the pair of electrons also shifting on toward the nitrogen. That's why it is the all are same side, upward direction. All the electrons are shifting toward the upward directions, right? But in case of NF3, sorry students, NF, nitrogen hydrogen, the fluorine is more electronegative, so that's why it's showing the nitrogen is positive, fluorine negative. And similarly here nitrogen positive, fluorine negative, and here nitrogen positive, fluorine negative, and pair of electrons are shifted upward directions, right? So it means, so this dipole moment, the pair of electron dipole moment with nitrogen and the fluorine dipole moment is opposite directions, right? Opposite directions, the direction is opposite, so that's why resultant moment of the NF3 is 0.8 10 to the power of minus 3 centimeter cube. Here the pair of lone pair of electrons and the hydrogens dipole moment remains on the same side, but in case of NF3, pair of electrons on the nitrogen and the 3 fluorine directions are opposite, so that's why the dipole moment is less here. So orbital dipole moment, the lone pair of electron decrease the effect of resultant of NF3. So lone pair of electrons which is decrease the dipole moment. The result, the low dipole moment of NF3 represented as like this students. Hydrogen positive, nitrogen negative, hydrogen positive, nitrogen negative, hydrogen positive, nitrogen negative, and pair of electron also moving towards upward direction, that is the dipole moment is away from the nitrogens. So but in case of NF3, the fluorine is highly electronegative, so that's why the fluorine is the negative, nitrogen positive, fluorine negative, nitrogen positive, fluorine negative, nitrogen positive, and dipole moment here, pair of electrons are showing upward direction, and this bond pair of electrons are showing toward the opposite directions dipole moment, so that's why the dipole moment is here less here. Right students? So here we will introduce in this concept, based on this concept we will introduce one more character, that is this is the covalent bond. this covalent bond showing the dipole moment hydrogen positive, nitrogen negative. So it means these electrons are partially shifted on the nitrogen like this, students. Right. When they are slightly shifted toward the nitrogen, it means the pair of electrons are shifted toward the high electronegativity element. This pair of electrons are the slightly they are shifted on toward the nitrogen. Then it develops partial positive charge. It is high electronegative, partial negative charge develop here. So it means the covalent bond, the pair of electron is present here, it is a covalent bond, but the charge is developed here, hydrogen positive, nitrogen negative. So that is the ionic characters it's showing the ionic characters. It means when the bond is present, covalent bond is present between the two different electronegative element, so the pair of electrons are slightly shifted toward the high electronegative elements. So that's why the partial positive delta plus partial negative delta minus partial charges are developed. So the partial charges are developed means this is the ions, so that's why it is considered as a ionic character. It is called as ionic character. Students, similar look at here, nitrogen here and fluorine. When you compare the nitrogen and fluorine, between the nitrogen and fluorines, covalent bond is present here. Pair of electrons slightly shifted toward the fluorine. Then the pair of electrons are here, slightly shifted toward the nitrogen. So it is the partial positive charge and this is partial negative charge. So charges are developed here. So it means the ions are developed here. Nitrogen positive, fluorine negative. So ions are developed. So it is the ionic character. So it is a covalent bond, but it's showing ionic character because of developing the charge. Right, friends? So that's why it is called the covalent bond which showing the partial ionic characters. Right? Partial bond showing the partial ionic characters. This is who's explained. This is explained by the Fezans. The Fezan is the person who has explained the covalent character present in the ionic bond. Ionic character present in the covalent bond. Right, students? And he explained one more thing. Fezan rule also explains the ionic compound. Ionic compound shows covalent character, which is opposite to this previous topic, students. He also explained covalent ionic compound of covalent characters, and in this slide we have discussed covalent bond have a ionic characters, right? So what is the covalent character? Look at here. Ionic compound like NaCl, KCl, MgCl2. Ionic compound formed by the cations and anions. Already we have discussed, students, right? So look at here. This is cation, positive charge. I mentioned here positive charge. This is anion, negative electrons, and this is the negative charge. So how many electrons it have? It have the 1, 2, 3, 4, 5 electrons. Right. When cations and anions are come close to each other, the 4 electrons, these 4 electrons are slightly shifted at the one end like this. The students, these are slightly shifted at the one end because these are the 4 electrons, 1, 2, 3, 4. These 4 are attracted toward the cations. They are slightly distorted their positions because electrons which are exhibiting the wave nature, so it means it cannot be fixed. The probability of electron is anywhere in the orbital, so they are slightly shifted. That changes the position like this. Look at here, it is a spherical position, and here the distorted position. This is the egg-like structure. So it means why it is happened, because the 4 electron, 1, 2, 3, 4, these 4 are transfer at the one end here, and 1 electron is here only. So it means the negative charge are distorted at the one end, right? So that's why negative charge polarize at the one end, so it is called as a polarization. It is called as a polarization, right? Electrons are shifted one end to another end of the atom, called as a polarizations. It polarizes. Right, students? It polarize means the electron density is here high and electron density is here less. Right, students? Here one end is high electron density, another end is low electron density. So why this happened? Why this happened here? Why this it changed the why this is change the position? Because it attracted to the cations. When cations are come close to each other, cations are strongly pulled all the electrons towards itself. It strongly pulled the all the electrons pulled. So that's why they are changing the position. So because of the cation, right? Cations, it polarizes. So that's why it is called as a polarizing power. Cation we called as a polarizing power, and anion is the polarization. Okay, this is polarization. Understand? Okay, get here lesson. So cation have a ability to attract the negative charge ion, called as polarizing power. Anions are electron tend to distort toward the cations, called as a polarizations. Students, understood? Okay, what is the role here? Cation. So which one is more strongly attract the which cation which is strongly show the polarization, polarizable characters? So it means the size of the cation, the smaller size, greater polarizing power. This is a small size: lithium, sodium, potassium. Look at here, lithium, sodium, potassium. The lithium size is smaller than the sodium size is smaller than the potassium. It means this is the small size. It means the electrons are the strongly concentrated with the nucleus here. Electrons are strongly concentrated with the nucleus. So that's why this small size of the element, which is the small size of the lithium ion, strongly show the polarizes the anions like this. This is strongly attracted the anions and strongly polarize the anions. That's why it is called as, that's why it is the small size is a strong polarizing power, right? Next is the charge of cation. Polarizing power increases due to the high charge. So all are same size. Sodium, magnesium, aluminum, all are the same size. But here +1 charge, this is +2 charge, and this is +3 charge. So here +3 charge means the here having the high charge, the polarizing power increases with the high charge aluminum ion. So aluminum ions which is losing 3 electrons. Losing 3 electron means here the effective nuclear charge is high here. Effective nuclear charge high, so that's why it's showing the high polarizing power. That's friends. Same in case of the anion also. Size of anion, larger size, high polarizations. Size of the ion, high polarization. Right here high, students. This is the right here high polarization, right? Why? Because larger size anions, here electrons and the nucleus between them weak attractions. Small size of anions, electron and nucleus between them strong attraction. So here they are loosely bonded. It means these are loosely bonded electron. These are the loosely bonded electrons. So that's why these electrons are more easily polarized toward the cations. Those electrons in the atom, those are loosely bonded with nucleus. So those are easily attracted to the cations, and these are highest, the large size in which electrons are electrons are loosely bonded with nucleus, so they are easily polarized by the cations. Right, students? So next is charge of anion. The polarization increases due to the high charge. Chlorine -1, SO4 2 minus. So here SO4 2 minus, here large, it is the having the high charge. The high charge which showing the high polarizations. High charge showing the high polarization because the size is large. Charge is large means electrons are distributed weakly around the outermost orbital. So that's why high polarizations. Right, students? So here in terms of following rules, the small size of the cation, larger size of the anion, it should be need for formation of the ionic bond. Sorry, the ionic characters in a the covalent bond in a ionic characters. So it must be the size of the cation and size of anions are the small size of cation, large size of anions are required. Greater covalent character of the ionic bond, greater charge of cation, greater is the covalent characters. Greater charge, cation charge is greater, Al plus 3, greater charge than Na plus, so greater charge, greater covalent characters. Cation have a same size and charge. Cation have a same size and charge. 1 electrons n-1 d ns0. So if cations have a same size and the same charge, in this condition we have to use those cation which following the outermost ns2 np6 and nd10 electrons. Those elements are following the after removal of electrons, their outermost attain the this electronic configuration. So such cations are show the high polarizing power. For example, copper, atomic number 29. Atomic number 29 means the argon 18, that is argon 18, students. And argon 18, that is the argon 18. Next is the 3d 10 4s1, right? Copper turns into copper ion 28. 1 electrons are removing, so argon outermost the 3s2 3p6 and 3d10, 3s2 3p6 3d10. So this cations, copper ions is the example. So if the charge is same, if you are using the sodium ion and copper ion, out of this copper, this is copper, students, out of this which one show the high polarizing power? Copper, we show high polarizing power because copper outermost attain 3s2 3p6 and 3d10 electrons, right? So that's why this show the such type of electronic configuration, the noble gas of the element, which the ions which attain the noble gas, which show the high polarizing power, right? Cation polarizes anion by pulling the electronic charge itself and the electronic charge between the two atoms. So cations are easily pulled the electrons. Cations are polarizes. Electrons are polarized at one end, so they are attracted to the cations. Right, students? So what happened in covalent bond? Build up the electron density between the nuclei. Electron density. If the polarizing power of cation, polarizability of anion, extent of distribution of anion, the factor which determine the percentage of covalent and ionic characters. So why the build electrons are density increases at the one end? If the electron density increases at the one end, the cation, and this is anion. So the when cations are attract, it deteriorate, electrons are deposited here, 4 electrons are deposited one end, it polarizes, and the polarization occurs in the anions. This is anion, so they are showing the attraction towards cations. So with the help, the pair of electrons are showing attraction toward the cation, so that is the covalent character. Right, students? The sketch bond moment of resultant of the dipole moment SO2 dipole moment, the sulfur and oxygens. So here sulfur and oxygens are shown like this. Sulfur outermost, sulfur 6 electrons, right? So oxygens sharing pair of electrons to form double bond. Here also oxygens sharing the pair of electrons to form double bond. Next, this pair of electrons are shifted this side, then it becomes negative charge and it becomes remains same like this. So it means the dipole moment is greater than 0 here, greater than 0, right? The next question, sir, from your NCERT, arrange the bond order of increasing ionic characters of the molecules. So ionic characters are increases between the metal and non-metals. Ionic characters are increased between the metal and non-metal. So metal electropositive, non-metal electronegative. It is electropositive and this is electronegative. Students, so ionic character is directly proportional to electronegativity difference between the two different atoms. So lithium fluorine, which showing the greater ionic character, greater ionic bond, the greater ionic character, because lithium and fluorine between them covalent bond is present here. Covalent bond present, but they are showing the ionic characters. Ionic characters like this, because dipole moment is different here. The pair of electrons try to shift it on the fluorine, that's why it is ionic characters. And potassium oxide, potassium metal, oxygen is non-metal. Again, the one oxygen attract the two potassium. So sorry, the opposite, like this, students. So dipole moment is greater than 0 here also. Chlorine fluorine, one chlorine attract the 3 fluorines. So fluorine high electron negative and then chlorine is positive. Chlorine is positive, fluorine negative, right? So it means it is the both are non-metals here. Chlorine, fluorine non-metal, so we are taken as third. Sulfur oxygens, sulfur oxygen between them resonance structure attained like this here. Resonance structures are attained, so they are also showing the less ionic characters. Nitrogen non-polar compound, so ionic character dipole moment is 0. Right, students? Understood? Thank you so much.